Welcome to the programming session on operators. Also, this type conversion topic. Okay, all are related. So I'll take it as a single session. So programming related to the operators. So we discuss it about different operators. Let us say integer C and D. Let there be integer C and D. Depending on the requirements, we will be declaring the variables. Integer C and D. Let C be say 3 plus 4 star 5. So typical example which we are discussing, we discussed it in theory part also. But what is the result of C? What is the result of C? Any guesses? Any guesses? Four star 5 20 23 or 3 plus 4 that is 12 sorry 3 plus 4 7 7 5 35. So is it 25 35 or 23? Is it 35 or 23? Let's check. Build. Okay, it is completed successfully. We are getting 23. We are getting 23. That means this 4 star 5 is evaluated first and then that is added to 3. That is added to 3. Now suppose you want 35. You want 3 plus 4 to be evaluated. Then what you can do? You can add parentheses. You can add parentheses. Now what happens? Build and then execute. So you are getting 35. That means the innermost expression is evaluated first. Whenever you use the parentheses, whatever is there in the innermost parentheses, that will be evaluated first. You can go to any level. Nesting of parentheses can be there. Please note that. So we generally don't use complex expressions. We always try to simplify them. So if the expression is complex expression, then it's better you divide it into different expressions and evaluate them one by one to avoid confusion. Now suppose D equal to again 3 plus 4 star, call it as 5.5. Now what happens? Let me add the print statement also. Okay. The value of C is 35. The value of D is 25. You are getting 25. What is happening? Confusion. Fashion here. D value is 25. Why I am getting 25? Why I am getting 25? 4 star 5.5. What is 4 star 5.5? Is how much? 22 plus 3. 22 plus 3. Okay. So 22 plus 3, no problem. It is I am getting. So because 4 star 5.5 is 22. Exactly 22 plus 3. Okay. Exactly 22 plus 3. That is 25. Now suppose I make it as 5.3. Let me check. So it is 24. Is it 24 exactly? No, it's not exactly 23. 4, 3, 12, 4, 5 are 20, 21, 21.2, 22.2, 23.2, 24.2. The value should be 24.2. Now I am getting only 24. Is it it? Isn't it? 4 into 5.3. What is it? It's 21.2. 21.2. 21.2 plus 3. 22.2, 23.2, 24.2. But what is the result you are getting? It is only 24. It is only 24. What is happening? So what is happening? Okay, it is converted. 4, 5, 4 into 5.3, 21.2 plus 3, 24.2. Okay, but you are assigning it to integer. D is integer. So that fractional part is truncated. That fractional part is truncated. Okay. So these things you should bother if you are working on numerical data. If you are working on weather forecasting related project, when you have large amount of numerical data, fractional values do contribute sometimes. Maybe a minor value, but when the amount of data is large, then it can affect. We will do one thing, float E. So float E. So what I am doing is I am going to write the same expression, 3 plus 4 star 5.3, 4 plus 4 star 5.3, and then print the value of E. The value of E is the percentage F, because it is floating type, percentage of fashion I will retain E. Now let us see. So now you can see 24.2, and the tricky one is the issue with computers. You can see it is not 24.2 exactly. Some again 4 zeros followed by 1. So computers cannot actually store it precisely. And sometimes when you print something, we will get 24.00001. So that is possible, except in standard compilers, the free and open, in majority of the free and open source compilers, you will get such issues. But they will not contribute much to the result. They don't affect the result. But point is, when the left hand side is integer, so that 24.2 got converted to 24. Whereas when the left hand side is floating point, that 0.2 fractional part is retained. 0.2 fractional part is retained. So that's why the value is 24.2. 24.2. Okay. So that is one. And let me try something else. Let me try something else. So here also what I will do is I will use E. If I use it, will be converted. What the trick I can play? The trick I can play. That is part converted. That is in here. That we cannot prevent it. Okay. So this is regarding some of the operators. So we'll take other kinds of operators, other operators. So let us say F, let us try to something else. F equal to 24 by 5. 24 by 5. F is equal to 24 by 5. Okay, what is the result? What is the value of F? What is the value of F? I get a surprise result also. Is that surprise? 4 by 5, what is it? So it is 4 only. Value of F is 4 only. So how do you write mathematically 24 by 5? Okay, 4 are 20. 40 remains. So is it 4.8? Okay, it is 4.8 actually. 4.8. But here what you are getting? 4 only. So what is happening? So whenever you divide in the computer, so you get two things actually, uh, quotient and remainder. Quotient and remainder. So when you use this slash operator, you will get only the quotient part. So if you want to retrieve the fraction, this remainder part, you can do it like this. So G equal to, what is the operator to get the remainder? 24. What is the operator? Percentage. 24 percentage 5. So what is the value of G is, what is it? G. Compilation failed. Why? Warning, GUC much error. The actual error. Expected semicolon. So error is the error. It is showing this line. Can you identify it? Red line. There is one error. Not about the semicolon actually. Something about something else. What is it? So here, that double quote, beginning quote, not available. Here you can see the quotient is 4, remainder is also 4. 24 by 4. Quotient is 4, remainder is also 4. So if you want to get remainder, you have to use percentage operator. If you want to get quotient, you have to use slash operator. Okay. So F is equal to 24 by 4, 4.8. According to mathematics, you don't get it. Okay. Let me try another trick. I don't know whether it works or not. I'm experimenting. Let us see. So what happens? So you are getting 4.8. You are getting 4.8. Okay, and reminder, it's okay, it is 4. Why I'm getting 24, this 4.8? So previously I got only 4. Why? So when you have these 24 and 5, they are integers. So if you supply two integers, integer division is performed. When you supply two floating points, so real division is performed. That's why I'm getting F as 4.8. So I think only one is enough. One is enough. Let me try this one. One should be enough. Generally it is the case. Okay. One is enough. If one of it is floating point, then one of it is floating point, so automatically the other will also be converted into the floating point. That we studied as part of type conversions. So widening rule. So one is integer, the other one is floating point. So the integer is also converted to floating point. Now I can do it other way also. Float 24. Instead of like that, I'll write float 24. What happens? I am getting the result 4.8. So what was the previous case? 24.0 by 5. What is the previous case? That is implicit type conversion or type coercion. Implicit type conversion or type coercion. COERCION. Type coercion. What is this one? Explicit type conversion, or in simple terms, type conversion. Explicit type conversion. So where 24 is actually an integer, I am forcing, or I am explicitly converting it into floating point. That is, I am making it 24.0. 24.0. So that is the syntax to be followed. So we covered that implicit type conversion, explicit type conversion also. Implicit and explicit type conversion. Now can you do, what happens if this one is integer? F is integer. If you assign it to integer, then what happens? Suppose this is D. And you print the value of D only. What happens? So I say that fractional part will go. Okay, here it is. Should be percentage D. So gone. It is only 4. The fractional part is gone. So you should be careful about the expressions. So definitely you are not going to work or restrict yourself to only these simple expressions. But if it happens, if you work with weather forecasting, remote sensing, or where there is large amount of numerical data to be processed, mathematical applications, statistics related applications, then you should be careful. You have to revise these things. And then work. Okay, and then work. But remember the rules. Integer division will be there, floating division will be there. Depending on your requirement, you have to use parentheses, you have to convert appropriately, etc. etc. Okay, so that you have to do it. What else? Uh, Precedence rule we discussed. And overriding the precedence rule using parentheses. Okay, next. Associativity. creativity equal to the printf the violation by expected colon. Exactly, it is precisely saying, okay, and here there should be semicolon that is missing. So H is 50. H is 50. H is 50. Is happening? H is 50. So 20 star 5 slash 2. 20 star 5 slash 2. So two operators of the same precedence. So what is the associativity? In this case, I think it is left to right. So 20 star 5 is evaluated first. 20 star 5 is evaluated first. So that is 100 by 2, that is 50. We are getting it. We are getting it. Okay. So if 5 slash 2 is evaluated first, then what happens? So because both are integers, integer division will be carried out. 2.5 will be converted to 2, and 20 star 2 it will be 40. If you want explicitly, I can override it and show it. Forty. You are getting 40. So it depends on the associativity here. Associativity rule. If it is because it is left to right associativity, no problem. Let me try another trick. Uh, one. Sir, is 52. You are getting 52. So instead, suppose write like this: 2, 5. Is the result? Is the result? The result is 50. What was the previous case? 21 by 2. What is 21 by 2? What is 21 by 2? 21 by 2 is actually 10.5. Actually 10.5, but it is because it is integer division, 0.5 is truncated, so only 10 remains. 10 star 5, that is 50. 10 star 5, that is 50. Okay. You may think that both are same. I think that both are same, previous one and the current one, but it's not true. 50 here. Now if it was like this, slash 2, previous case we had 40. Now what is the answer? 52. 52. So that is left to right associativity, right to left associativity, etc. Here we are not using right to left associativity, but we try to override it. So the point is, so whenever the operators are of equal priority, associativity comes into picture. Associativity comes into picture. So that you may have to be careful. Maybe with respect to the for loop, there you use the comma. Comma operator is also left to right. I think there are two cases where where the associativity is right to left. So you should be careful. Those two cases we have to remember. Those two cases we have to remember. In all the remaining cases, it is left to right. In all the remaining cases, it is left to right. What else? What else? The mistake we sometimes end up with is, suppose instead of, because h is integer, I have to use percentage d, accidentally keep it as percentage f. Then what happens? Compilation, no problem. Value is 0. The value is 0. You are getting 0 value for h. So if you accidentally use wrong format specifier, you cannot expect the correct values. You cannot expect the correct values. So the format specifier should be correct. So the format specifier depends on the value you want to print. So if you want to print integers, percentage d. If you want to print floating, percentage f. Percentage f. Okay. So it depends on what you want to print. It depends on what you want to print. So these are the arithmetic operators. Relational operators is better we discuss with the conditional statements. Control structures chapter is there. There we will discuss. What else? The guys operators. Guys operator. Thing operator. Guys. Okay. So H is, let us say 4. H is 4. H equal to H equal to H by 2. F D H value is 4. So we use the shifting operator. What happens? What is the value of H? H is 16. Why it is 16? H is 4. After shifting, it is becoming, after shifting, it is becoming 16. What is it? Why? So the H value is 4 is binary. So you can say the remaining will being zeros, 1, 0, 0. 1, 0, 0. 4 is actually 1, 0, 0. 4 is actually 1, 0, 0. 4 is 1, 0, 0. Okay. 4 is 1, 0, 0. Shifting by 2. Shifting by 2. By 2 actually. That means twice. Twice you are shifting, not just once. So what happens is, You are shifting left. This is left shifting. So what happens is, so 1 will move 2 positions. That is, it will become 1, okay, 0, 0, 0, 0. So if you shift once to the left, 0 enters at the right end. So again, if you shift another 0, so it is 1 followed by 4 zeros, which is equivalent to 16. Which is equivalent to 16. Okay. Which is equivalent to 16. That's why you are getting 16 as the output. So that is left shift. Left shift. You try the right shift. Now it is 16. Okay. After left shifting. So if you want, can again try it out. It is battery's problem. Replace the battery. Complete this. So if it is right shift, so that means we have shifted left twice and shifted in the right direction by 2. So you should get the same result, that is 4 only. So left shifted, right shifted, so compensated. So what is it? You are getting 4. You are getting 4. So let us shift by only 1. Right shift is only once. Then what happens? So the value is 1 followed by 4 zeros. After left shifting, 1 followed by 4 zeros, that is 16. So you are right shifting by 1, that means it will be 1 followed by 3 zeros. 1 followed by 3 zeros. Now what is 1 followed by 3 zeros? So it is 8. It is 8. So that is regarding the left shift and right shift operators. Left shift and right shift operators. So you want see if this is the binary form of a number, then if you left shift by 1, what happens? It will become this 1 will go, this 1 will go away. Okay, it will be 0. It will be 0 0 1 1 0 1 1 and 0 will enter here. 0 will enter here. Okay, if it is left shift, if it is right shift, then 0 will enter this side. It will be 1 0 0 1 1 0 1. So that one will go away. That one will go away. So shifting of the operators. You know, you will not be using much of this shifting, but internally actually computer uses this shifting. It uses these low level programs actually uses shifting extensively for multiplication, for division, etc. They use shifting. Those algorithms will multiplication, etc. They will be converted into this shifting type of algorithms, because computer can easily do this shifting, left shifting, right shifting, etc. So remember, what happens internally is totally different. Okay, already always it considers efficiency. Always it considers efficiency. So multiplication, division, etc. are considered as costly operations. Are considered as costly operations. It's better if we can convert them into additions and subtractions. Additions and subtractions. Instead of writing 2 star 2, it's better you write 2 plus 2. So we don't notice the time difference. We don't notice the time difference. Okay, for one, we are not noticing. Suppose 1 lakh such operations you are doing. 1 lakh such operations. So that means so you are processing 1 lakh records of a student in for every student that 2 star 2 is there. Then you can see the difference. You can see the difference. Then you can see the difference. So don't underestimate the value of any simple computation. It depends on how much data you are processing. Now we are in the data science field. We are in the data science field. We are talking about data science. So you should be careful. You should be careful because we are going to deal with a huge amount of data. Huge amount of data. So try to write the programs efficiently. Okay. F shift, logical and bitwise and bitwise and. And let me show it one also. F D are there. We'll consider CD. C equal to say 4. C equal to 4. D equal to 8. D equal to 8. Okay. Now bitwise one only. Okay. H equal to 4 and sorry 4 under we will use C and D. C and D. Printf value of H is okay. Percentage D. Compilation failed. Why? Compilation error. Value of H is 0. Why? The value of H is 0. So if you take 4 is 100. If you take D, it is 1. Okay, 1 0 0 0. So that is 8. So try to position it correctly. Okay. So logical and the bitwise AND means so bits will be 100. So 0 0 is 0, 0 0 is 0, 1 0 is 0. So if nothing is there means here also there is 0. So 0 1 is 0. So all zeros. So that's why you are getting the value as output as 0 only. Got output as 0. You might have observed it. Okay, output as 0. Output as 0. So 0 0 is 0, 0 0 is 0, 1 0 is 0, 0 1 is also 0. Actually here there will be 0. So all are zeros. All are zeros. Now, what is that logical OR? I have to remove these things. Okay, just remember. So 4 and 8 are there. These are the binary representations. You can note down. Now I will do the OR operation. I will do the OR operation. I will do the OR operation. What happens? What I get? 12. What is it? Why 12? 12 is 8 plus 4. How I got 8 plus 4? So first 0, 0, 0 is 0. 0, 0 is 0. What is the next one? 1, 0. That is 1. OR operation. Because 1 is there. So 1, 0 is 1. 0, 1 is also 1. So 1, 1, 0, 0. 1, 1, 0, 0. So that is nothing but 12. That is nothing but 12. That is nothing but 12. Okay. Is there any operator? With the operator? Is there any operator like that? Is also 12 exclusive OR operation, but it is also 12. Okay, because 0, 0, 0 if both are same, we'll do the other thing for this one. So if it is and what is the result? What is the result? Result is 4 only. Check it out. So you can see the result is 4. The result is 4. Okay. But let me do exclusive OR operation. Then what is the result? What is exclusive OR? It will be 1 if they differ. If that means if the two bits differ, it will be 1. Otherwise, it will be 0. So it is 1, 0, 0, 1, 0, 0. 0, 0 same. So result is 0. 0, 0 same. Result is 0. 1, 1. Result both are same. So it will be 0. So the expected result is 0. Let us check. So you can see here 0. So exclusive OR operation means, so it will be 1 if the inputs differ. If the inputs are same, that means if they are both zeros or ones, the result will be 0. The result will be 0. The result will be 0. So this is bitwise operators. Bitwise operators. Bitwise operators. Bitwise operators. Okay. I hope this is enough for you. I hope this is enough for you. So all these things work on simple problems. You will get to know about all these things. So it's not an issue. It's not an issue. So remember, again, I repeat, the purpose of learning any programming language is to solve the problems. Okay, to solve the problems. Don't spend too much time on trivial things. Trivial things. Some people do it. Okay, changing the width, etc., etc. So remember, you are an engineer. You are not an artist. You are not an artist. So an engineer has one ability. A few years back, I went to KSRM, the chairman's son, Josh Reddy. I remember. So he told one point. He told one point. Uh, the point is, the point is, uh, to take these technicians, etc. Car technician is there. So what he can do, mechanic or technician, what he can do, so if you can give him the spare parts, different spare parts, he can always build the car. He can always build the car. He knows it. But engineer is one. Engineer is one. Given these spare parts, so he can build the car. He can build the mic. He can he can build the bike. He can build the car. He can build the tractor also. He can build the tractor also. So he is capable of doing it. So that is engineer. That is engineer. So don't think that you will not be encountering any new problems. You will be encountering the new problems because you are an engineer. You should solve them. And some technicians will come and try to insult it. You don't know these things. So in my childhood, there was one Tamil neighbors. There were Tamil neighbors. Okay. That person used to tell, my son has very good general knowledge. Your son doesn't have. It's okay. Everybody will have some advantage. It's okay. Everybody will have some advantage. Now people scold me. Even my wife tell me that I don't know whether these things are to be recorded or not, because I am recording it. No, let me complete. So నీకు లౌక్యం తెలీదు. It's okay. There will be different types of people. సో అడవిలో వివిధ రకాలైన జంతువులు ఉన్నట్టే మనుషుల్లో కూడా వివిధ రకాలుగా ఉంటారు. ఎవరి జీవితం వాళ్ళది, వాళ్ళు బతకాలి. ఓకే, థ్యాంక్ యూ ఫర్ జాయినింగ్.